River Mining, impactos de la minería aluvial en la cuenca de Madre de Dios, efectos físicos y un planeamiento para su mitigación. Una investigación valiosa para la toma de decisiones en base a evidencia científica. Investigación y tecnología con propósito. Para mitigar los impactos ambientales en nuestros ríos, debemos estudiarlos y monitorearlos. Por eso, durante 2 años, un equipo multidisciplinario del Centro de Investigación y Tecnología de Agua de UTEC y del Centro de Innovación Científica Amazónica estudió, investigó y recogió información sobre el transporte de contaminantes, la dinámica física y la biodiversidad del río Madre de Dios. Hoy nos anima a entregar un aporte científico que contribuya a las soluciones basadas en la investigación, para favorecer al país y las comunidades relacionadas que dependen de los ríos. Promovamos juntos la investigación previa a la intervención en ríos, a través de un sistema integral que permite evaluarlos y monitorearlos adecuadamente.
Good afternoon. My name is Elisa Portocarrero, coordinator of the River Mining Project. To those that are just connecting through the Zoom application, let us remind you that we have simultaneous interpretation to English. At the bottom of the screen, you can see the world icon where you can select the language of your preference. If you want to hear it in Spanish, please select and click Spanish, and same thing with English. Welcome everyone to this closing event of the project that has been developed to the Center of Development and Research of Water, UTEC, and Scientific Amazonic Science Center, with the collaboration of the Department of the USA Agriculture Department and the financing of the peer program from the USA Agency for the International Development, USA.
Este evento tiene como objetivo.
This event has a goal of spreading out scientific information that been generated regarding the effects of the river mining and the dynamic of transportation of water and sediment of Madre de Dios River, and its interrelation with the mercury transportation and its effect in biodiversity. Thank you everyone for being here with us in today's task journey, and tomorrow too at the same time, where we will have the participation of institutions of the government and civil society that are involved in the management of these rivers. Let us remind you that the panelists and speakers to keep your muted mics and cameras off while you are not making a presentation in the event, please. Thank you very much. And with any further ado, would like to mention also that if you have any doubt or question, please let us know in the chat that's in the right side of your screen. And to those that are following us through Facebook Live, you can write first the name of the speaker that you're going to ask your question to, and at the end of the presentations, we will have a space to solve any question. It might be with mic or in a written form.
Dando el pase al director del Centro de
Investigación. Start with the event, given the mic to the director of Center of Otter. Please, Patrick. Patrick is a biologist with a master's and a PhD in France, with an expertise in environmental science and biodiversity. His research goes around 3 main axes in ecology of community, the source and keeping the biological diversity through mechanisms that are ecological and evolving mechanisms. The effect loss of biodiversity on the functioning of systems and the protection of ecosystems facing anthropic activities. He's a current member of the Environmental Engineering Faculty and from the Research Center and Water of the University of Technology in the mining project with the hydrobiology. Yeah, please go ahead, Patrick. Hi, Elisa. Thank you very much. Good afternoon, everyone.
For those who prefer to follow this presentation in English, you can find in the lower part of the screen an interpretation option, so you can follow in English if you wish. Antes de empezar el evento, quiero agradecer principalmente.
Before starting with the event, I would like to thank the whole event of CITA and CINCIA has been involved in the process. We have a few remarks that we prepared with the team so we can open up this 2-day event, as Elisa mentioned. The Andes feed off with water and sediment to the Amazonic basin through their rivers. They are primary source of substrate and nutrients that will mold its geomorphology and nurture its ecosystem It helps us with the Amazonic landscape, and it's important to manage rivers, water, and sediments to prevent or mitigating impacts that might be caused by anthropic pressures, such as the extractive activity that alter their balance and equilibrium.
Centro de Investigación.
In 2017, the Center of Development of the CITA University of the Tech University has been developing research about rivers in the Peruvian Amazon. In this context, we have generated synergies with institutions such as the Center of Scientific Innovation, the CITA, which is an institution that just as it studies the importance of the rivers to have a better understanding and management of them. Madre de Dios region is a focus of biodiversity that's been acknowledged as the capital of biodiversity of the country. However, it's also the region that's most degraded in the Amazonic jungle for over 3 decades of intense river mining and legal and illegal. In this context, is evident to support with scientific knowledge to government institutions to generate or improve public policies for Amazonic rivers. That same way, to strengthen technical capacities and initiatives of scientific research in the Madre de Dios river basin. The river mining project impacts of river mining in the basin of Madre de Dios River, its physical effects, and planning for its mitigation through the different groups of work that have studied the complex dynamic of the Madre de Dios River and their different points that we today detail and will have results introduced to us. It's a pleasure for me to give you the welcome to this closing event, Science to Study Environmental Impact in the Madre de Dios River. Thank you very much and welcome again. Thank you very much, Patrick. Now we'll have the inauguration of the event in charge of Kerry Reeds. Kerry Reeds is the Attaché Director of Environment and Sustainable Development ESG Office in USA Peru. He is a PhD by the Missouri University. He has over 11 years of experience working in USA, including the allocation in Philippines and the Pacific Islands, the regional mission of South Africa, and recently Bangladesh. Before USA, Mr. Reeves who worked as a research biologist, investigating and researching the effects of the change of flow of communities of fishes in the Texan rivers as for the study of endangered species. Please go ahead, Kerry. Thank you very much for being here with us.
Great, thank you, Lisa. Good afternoon, everyone. It's a pleasure to be with you all today. For the last 10 years, USAID has worked with the U.S. National Academies of Sciences and a myriad of universities and partners around the world through the Partnership for Enhanced Engagement and Research, or PEER program, which supports scientific research to find solutions to global development challenges. And now, since 2020, the Amazon Scientific Innovation Center, CINCIA, and CITA UTEC, along with the support of the U.S. Department of Agriculture, have investigated the physical impacts of mining in Madre de Dios River Basin. This is incredibly important research. It touches on how mercury moves through the environment and through the food chain. As we know, mercury is a very toxic metal, and the biomagnification of mercury as it moves up the food chain, such as through predatory fish species, can place communities that are very reliant on those resources at increased risk. So as this research is wrapping up, the next step is to translate these findings into the language of policy and decision makers. And so that we can promote the changes in current mining practices that are needed to protect the environment and human health in the Amazon. Thank you all very much. I'll turn it back over to you, Elisa.
Gracias, Kerry. A continuación, como
Thank you very much, Kerry. And we'll have also a technical presentation of the project in charge of Monica Moreno, who is a researcher and the coordinator of projects in Investigación and Tecnología Center, CITA, UTEC. She is licensed in chemistry of the Pontificia Universidad Católica del Perú and a PhD in environmental geochemistry from the Freiburg University of Bavaria, in collaboration with the Brunswick University in Germany. So far, the 10 years of experience researching the behavior of mercury related to mining in the aquatic system in the Madre de Dios system and its accumulation in the wildlife. It's also researching the effect of the glacier decrease in Peru having an effect downstream in the river mining project. She has the position of main researcher, and she is the researcher of the main packet of pollution by mercury. Please go ahead, Monica. Hi, Elisa. Thank you very much for that presentation. I will share my screen now.
¿Me confirman, por favor, si la pueden ver?
Can you confirm that you can see it?
Sí,
Yes, we
gracias.
can.
Bueno, como
Thank you.
bienvenidos a todos.
First of all, welcome everyone. Thank you for being with us. And
Para todo el equipo.
it's such an important day for the river mining team, which is the closing of our project.
Nuestros colaboradores y a todos
We
los asistentes.
want to thank all of the collaborators and speakers. And now, really, I'm going to give you a brief introduction. Patrick and Kerry and Lisa have already told us what's going on in Madre de Dios. So, without any further ado, let me introduce to you how does a photograph look? How do we all think our Amazon looks like in the southeast of the Madre de Dios area, which has been declared as the biodiversity capital by our government. There's a biodiversity focus worldwide, and in many sectors, we can still see it and think of it this way. But however, artisanal and a low or small scale mining has transformed a lot of areas of our Amazon riverside. These are areas that have been degraded more in Peru, in the Amazonic area due to this sector, and a lot of the ecosystems and landscapes sadly look like
Basado en esto,
based on this, is that we have this river mining project born, looking for not just generating new information, but also complementing research that as of today we have been developing. And with that, we have a vision of a project, a general view, knowledge, generating science, and being able to make better decisions to and for the development and management of our Amazonic rivers, especially those that have been impacted by illegal mining and informal mining, gold mining by that. And on this vision, we have started working, or we've been working in the last 2 years in our main goal of researching the effect that this activity produces that happens in rivers. What is the harm that causes to our geomorphology of Madre de Dios basin, and what is the impact that this generates in sea, wildlife, and marine bodies. And as for the spreading out and dissemination and transportation of mercury, and looking at if finally there is an aspect of a risk for the human health and the health of the wildlife around it. So with that goal in mind is that we start to develop this type of work, our project, in 6 main core axes: pollution by mercury, remote sensoring, hydrobiology, hydrogeology, to understand how our rivers behave, numeric modeling that has to do with the hydraulic type modeling, and then the communication side of it all and spreading out so we can disseminate and generate capacities within our governmental stakeholders. So we focus in the research study in the Madre de Dios region, which capital is Puerto Maldonado, and we have worked in the Madre de Dios River as addressed here from the Ichirihue River. That's located in the highest side covering Colorado River and in Ambari River, which are those that receive or the highest, or that are the highest mining areas of the region. Briefly, not to come into much detail because my colleagues are going to tell you a bit more about what is that we've done and what are the results, what have we obtained. Our working packet for hydromorphology about how does it behave, hydrodynamic of rivers, how is it that they change in different parts of the river, if they are influenced by the presence of mining or not, what is the quality of sediment, if they variate or they change in the different levels. Then the remote sensors also
de otro análisis.
identify how river flows, but doing a different analysis also with satellite imaging that changed throughout the years. What are the parameters that we should take into account to understand the dynamic of rivers? And also we have the modeling, the numeric modeling package to see how the
de los sedimentos,
flow
cómo se
behave,
transporta
what
el agua,
the
si es
transportation
para
of
ver
sediments like, what the transportation of water like. If sedimentation is going to increase transportation of water, are we heading with this? Is it going to increase the basin or not? So also in charge of our CINCIA colleagues, all of this physical side of rivers and stuff, how does it translate to biodiversity? If we find the same microorganisms or aquatic organisms, or if you can or not, if they're changing or not, they have if they suffered an impact, or what is the impact in the basin. And this work package that is also led by CITA also focuses on mercury. Where is the mercury? Is it in the sediment? Is it in fishes? And
es
the same amount throughout all the fishes?
salud o
Does it
no.
represent a health concern or not? They are the ones answering that question. And finally, our working packaging, communication, and incidences that we are not the only keepers of this information. Of course, it is of scientific interest, but we also want to spread it out. We want to transfer this knowledge and build capacity for decision makers, for the civil society, and for the overall public. And we hope that today they take away a message back home about how can we manage or what's going on at least with these rivers, and what's the best way or the best strategy that we could adopt to manage it better. Thank you.
Muchas gracias, Mónica.
Thank you very much, Monica. And carrying on with our program, we have Leo Guerrero, who's going to let us know about technical results of the hydrogeomorphology results. He's a master in engineer with hydrologic
En hidrogeomorfología
from the University and hydromorphology in rivers, specializing in the Amazon. He's a professor of civil engineering from the Technology and Engineering University of UTEC, leading the Center of Research and Water
ha
from
investigado
that same university. They research about the physical dynamics of the Piura River, Guayaga, Marañón, Ucayali, Amazonas, and Madre de Dios River, and the relation with the development of hydraulic infrastructure and the activity impacts of the respective activities of project financed by CITA, which is the Gordon Foundation and Betty Moore and USA. The Leader Mining Project, we have the river focused type of measurement, so we can go ahead and understand a bit more of this. Please go ahead. Thank you very much, Lisa.
Bien.
Okay.
El título de mi presentación es
The
Impacto de
title
la
of my presentation is the impact of the
cosas que ver.
river accreditation in the Madre de Dios.
Decidimos dentro del
There are many
paquete.
things to look at in the Madre de Dios River, but within this, we wanted to show you this specific problem.
Paisaje muy típico cuando uno visita
This is
el
a really
río Medio
typical landscape when you visit Madre de Dios,
del río.
and you can see the
Bosque,
river area,
opaco,
forest, but we also see this type of area here, which floods this area, but it's not only doesn't flood it,
parte
but
del ancho del
also
río, principalmente en
it
esta
takes away a big chunk of the width of the river. In this area right here, that's known as beach or point bar in our literature,
En esas zonas se hacen
in these
actividades de
areas,
extracción
we have this extraction activities happening
del oro.
with the means of obtaining gold.
Resulta de esta actividad de
What turns out on what
extracción
of this activity of extraction is
de este material grueso, es un
this
material
type
grava,
of material, this gravel, is commonly sunlight,
que es finalmente
and
dejado en
it's
el río.
finally left there in the river,
Que cuando
and we
uno
have piles of
recorre
it.
los puede
And
identificar
when you go through the river, you can just see them clearly.
Cogimos material de este tipo
We took some of this material with the residue that we get from mining this
metro, nosotros
gravel. For example, putting in a 1 by 1 meter frame, we can see that there's even
material que tiene de 20
20
centímetros.
centimeter diameter material. what happens with this
el río
material and what happens with this material in the river? This material that it's in this beach-like area, it remains there in this beach area, and when the river increases its flow, the bottom of the river
de tal
decreases
manera que ese material por
in a
el
way that
peso comienza a caer.
the weight, that material starts collapsing down in a way that it ends up
Muchas veces en el
deposited
fondo,
most of times
fondo
in the bottom of the
en la
river,
parte más baja.
in the
¿Qué
lowest
sucede? Que cuando
of
viene
the
otro
bottom.
evento, el río no va a
What
tener la
happens when there's another
posibilidad
event? The river is not going to be able to erode anymore, or in any given case, it won't
sedimento que
have the
quedó en
possibility
esa
for the
zona
sediment
pueda
that was remaining
resuspender.
there can be resuspended or reflowed.
Sucediendo en
So
nuestros
that's
ríos,
happening in our
el
rivers, in
el río no
Madre de
tiene
Dios
la
rivers, because
capacidad
rivers,
o
or this river doesn't have the capacity,
no está pensado, o sea, no está, esto
meaning this is not thought
del
as
río.
or not, this doesn't happen as a natural process of the
¿Qué
river.
sucede?
And
Que
I will
estos
see this
montículos
clearly.
que están aquí,
But these piles that we have
dejados
here,
por la minería,
which are just left there by mining, after some stream events, the river itself starts
la arena que trae el río,
eroding
comienza
it and
taparlos,
covering it with sand on the sand of the river itself, and finally it ends up by covering those piles. So the river has the capacity of interacting with that material, it has the capacity of moving it, that material that is just left exposed in the river.
¿Cuál
So
sería
for us to be able to assess what the impact is that this type of material would generate, that is the result of mining, we identify different areas of work. The triangle areas are areas of non-mining. These are areas that are
son zonas de no minería,
declared non-mining areas, and the square areas are mining areas. Being the most impacted or the highest activity happening in this area right here, which is around this labyrinth area right here. And as we can see here, before starting and showing you all this result, we need to know a bit more about this river. This river is
ríos de la
different
parte
from
norte
the
de la Amazonía.
northern parts of the Amazon.
Colorado y Nambari tiene
Between Boca Colorado and Inambari, they have a slope, an hydraulic slope that is an average 26, 27 centimeters per kilometer. And taking into account the Guayaga River, for example, which is 10 or 11 centimeters per kilometer, the Amazon River Peru has 5.5 centimeters per kilometer, which is, this is a different river. And it's probably made out by sand and a certain amount of gravel due to the slope that it has. In Puerto Maldonado, more like the slope decreases completely to 1.2 centimeters per kilometer. However, if you've been there, you also see a geological presence that you need to take into account for this. Here, the only station that where we have information from is the Amarumayo station, which is in the Puerto Maldonado area. Maybe downstream, a few kilometers downstream, because we have Boca Colorado. Here in Ambari, Monica mentioned that these are the rivers that present the highest impact due to mining. But what type of information this is relating to? Well, they give us information about that in the lowest season, the river can have plus or less 4 meters, and in its highest plus minus 6 meters. That's why the river ends up covering all of those piles that river mining left. The field check that we've done in March 2022 and the lowest season in 2017 and November 2020 were our highest measurement points to understand this river morphology that Madre de Dios River had. This is regarding level, but regarding flow, we can observe the superior line, which is the highest recorded flow and the minimum as well. Here, there's something quite interesting. In 2021, we registered a flow of 20, or in the area of Amarumayo, 29,137 square meters flow. And this is a peak flow that breaks the average, but it is the registered value that we have in the Amado station.
Para poder entender qué
To
es lo
be
que está
able to understand what is going on, what's causing this degradation, we need to understand that we need to be there with positioning teams and making profiles in river in a way that we can understand how is the behavior of the river itself. We place sensors in a boat, we
acústica, podemos medir cómo
used acoustic equipment, and we were able to
lo
measure how
ideal
the
o qué es lo
bottom of the river was like.
ver
What we wanted to do or to see
es
in
lo
our
siguiente.
measurement was as
En un
follows.
de medición,
Red, we have in blue, we have our
que
solution.
debería
We
estar es
need to
que
observe
una
or is
medición
to have a matching between one measurement and the other, so we
fondos
can
estamos
see
viendo.
how much this it's like doing a tracking
Como
to
ven, por
this
varios
type of
kilómetros,
places.
al hacer un simple
In
desfase,
several kilometers,
un match
when
perfecto con la
only
primera medición, ¿no?
a
Se puede
simple movement, we can see that there's a perfect match.
mucho movimiento de
We see here that there's not
no
much
se observa
bottom, as well we
alguna
don't see any peak or any
variaciones
which are
que
good
nosotros hemos
type of measurement. Those are made are
tener.
something we
Entonces,
get to have.
en esas
So
mismas
in
zonas,
those same areas that I showed you, they are which
diferentes
is a non-mining area. We have
también. Lo que observamos
and
es
what we see here is that there was in certain areas this type of movement as a dune train, that's what we call it. But we also see some dune
una
that
medición muy
saw
blanca. En la primera
these
medición
areas
se
were
veía
too
como
flat.
una
In the first measurement, they seemed to be dune-like, but in a second measurement, it was too flat. Maybe because of this gravel that flattens the natural motion and flow of the river. But we also observed that
diferente
measurements
entre
were completely different from one another,
entre
not
una y
as
otra.
seen in other measurement.
Esta grava otra vez
Maybe
está
this
afectando el
gravel
comportamiento.
there's some sort of creativity that we need to take into account. We're observing changes in the face of the bottom. When we start being statistical about this dune length, which is a typical statistic that we look for, what we want is to find a correlation. And what we see here is, or these lines are different formulas that we found in different rivers.
En varios ríos.
In different rivers.
Lo que observamos acá es
And
lo que
what
nosotros estamos
we see here is that what we are finding, there's not a established trend. These are our first measurements, though. So we need to remember that these measurements were taken in November, which was a transitional season, and there's not so much of a value as we could observe in different rivers that have a completely different bottom.
Y al poder
And by observing, for example, that these were the first measurements of transportation of bottom that we were looking at, we've never seen a measurement such as this. What we see is as follows. MDD11 and MDD10 measurements that are before Rio Colorado or Boca Colorado, they show transportation lines of 60 and 50 tons per day.
por ejemplo,
Maximum value, of course, because we register here maximum value, average, and the lowest. We do have zero values as well. And as we are moving forward and transportation decreases, we see a peak in MDD7 because maybe the area is a quite lengthy patch and narrow, so that might cause it increase. But what we see here that these after this peak, the transportation starts decreasing, which we believe is kind of strange or is not behaving the way according to the yellow line that is followed. This yellow line is here represents the unitary flow, and as the flow increases, the transportation should also increase. That's what it's supposed to happen, but we are not detecting that. When doing this unitarily measurement, we have a relation beyond width and length or whatnot. We don't appreciate that. What we see is that there's a decrease, at least in the maximum values, and especially in the highest value areas where mining is causing the highest impact. So when we analyze the bottom material of these rivers, we notice that MDP 11, MDP 10, we found big material. This is a 20 centimeter ruler. So we found this type of big thick material. And that's when we see and we say, okay, we correlate this. This is a slope. It's not quite such a small slope, so the river still has a transition between the mountain and flat area. That's why it shows some flat or some thick material, some gravel. So when we see MDD6 or MDD4, this gravel still remaining, but it's smaller, maybe because of the change, but in this area, when you visit this area, there's a greater amount of gravel here than in the river, so we still have this material in river. In case where we start investigating, researching a lot more because this gravel, you get it from underground. And that's how we started assessing with different teams that allow us to assess bottom sample to map. We know that there's a sand layer in the river, and maybe downstream we have a gravel layer. So what mining does is takes out all of this gravel layer, or first they take the sand layer until they reach the gravel layer, and that gravel can be exposed when we have a high flow. But right now what's happening is that it's exposed by the mining activity itself. And using bottom profiler equipment, we were able to find this detail. These are some measurements that we've developed in the most critical areas and before around the labyrinth, and we map this. What we see here is water, and then our first response would be the bottom of the river. And then we understand that this response here, after the bottom of the river would be the flat layer. And then we have a different response that would be the change between the transition of sand and gravel. So the river had a low depth, in this case 5 meters, we are finding gravel. So the river naturally has a mix of sand and gravel, but mining is increasing this amount of gravel. How much we need to assess that a bit more essentially how much gravel is coming into this, but it's quite a lot we can say. In conclusion, what we have are rivers that apparently could be a sand bottom and it doesn't have a behavior. What we see that it doesn't have a natural behavior of this type of dunes that have a defined shape. And due to this activity that exposes this thick material around the river, and the river, when it increases its flow, it combines it with the sand that it brings in a way that it changes completely the shapes that we have in the bottom, and that naturally changes through a whole process. And this is put into evidence thanks to layers that we can find. So mining is able to extract that gravel layer that's at the bottom of the river. And given that it's really nearby the bottom of the river, we see that it causes a greater impact in the river. And what's going to happen then, that the transportation of the bottom of the river is going to start to decrease, and it starts generating changes in the river and in the natural erosion and position of the river when we lose it completely. Thank you very much, and I'll be up to your questions. Thank you.
Thank you very much, Leo, for your presentation. I'd like to remind the audience that they can enter their questions to our lecturers in the Q&A in a Zoom and in the comments in Facebook Live, so that lecturers can answer either orally or in writing. Okay, we will now present the results of the remote sensing work group that I was part of. This presentation will be by Julissa Estrada. She's an environmental engineer by the Universidad de la Selva. She is an expert in sediments in Amazon rivers and in monitoring physical parameters of rivers and water quality. She was coordinator in the sediment and water quality lab at the UTEC. And in the river mining project, she collaborates with Science and UTEC, is responsible of remote sensing and as a researcher of pollution by mercury and hydrogeomorphology. Julissa, you have the floor. Thank you very much. Good afternoon, everybody. I'm going to talk about part of the results of the remote sensing group, and I will focus on assessment of morphometric patterns in the Madre de Dios River and the changes generated by river mining between 1984 and 2020. First of all, I'd like to highlight that this continues the presentation by Leo. Although the morphometric patterns and degradation are in the same space, there are cause and the consequence. As it was formerly mentioned, the Madre de Dios River has some characteristics that make it quite particular. One of the main factors, for example, is that mining does not only contribute with a big load of sediments due to deforestation, which is also part of the activity, but also that it is carried out over the river. That means that we have artisanal that include only suction pumps, and there's also a much more mechanized mining that also works with heavy machinery. Based upon the evaluation by CINCIA in 2017, we can have the information on deforestation caused by mining since 1985 and how it has been directly related to an increase in the price of gold. We have parts like in 26 or 2012, there was an increase of gold price, and then radically the number of deforested hectares increased to expand the mining zone. So our research question is gold mining altering morphometric patterns in the Madre de Dios River? This is our planimetric characterization using satellite images, and we have determined static and dynamic parameters. With static, I mean sinuosity, average width, also the breadth of the river, and in the other case, it's the erosion mainly. We have used satellite images. We have been working with NTBI, and from there, we extracted polygons and the river's central lines and also the other channels. Additionally, we have worked with the geological valley characterization with the flooding valley, and we evaluated from 1 year to the other, determining the central line of the valley every 10 kilometers to be able to evaluate. River polygons have changed along the years. And additionally, we have evaluated geology and the rivers and its historical records. We characterize the paleo channels recorded through satellite images. Our time assessment was between 1984 to 1990, then 96 to 2001, then 2001 to 2006, 2006 to 2012, and 2012 to 2019. We were able to determine that this study zone has quite a varied geology. On the left, this is a photograph of an area that is upstream of the Inambari River, before the Boca Colorado River, and we can see there is a flooding plain. On the contrary, on the right, we see a natural rock barrier. This is downstream the former one, and this gives us an indication that there is a plain, right? In simple words. However, the fact that we know the study area shows us that there's varied geology with peculiar characteristics as compared to other rivers in the same altitudes, which are also considered navigable rivers. There are some other barriers. In the case of artisanal mining or mining on the beaches, on the river beaches, most mining activities and most miners generate barriers that act as riverine defense to protect the extraction area, and also they proceed with mining through suction pumping. These barriers seem small when we see them like this or from a satellite, but when we go to the place, look at the size, it has sediment accumulation from 3 to 15 meters high, and the wells they generate can have more than 10 meters deep. In this photograph, we can better see the comparison with people who are working and the excavation. Now, this is part of our results. We have been able to identify how the central line of the river has been displaced a long time. In the case of the red lines, those are the older ones, and the blue lines are the most recent one. And if we compare 1984 in red and 2012 to 2019, we can see that there was a lot of displacement in the number of meters that the central line was displaced in different areas, as compared to 2012 to 2019, where this line, 10 kilometers after the Boca Colorado River, is practically zero. So there's a decrease, or there's a limitation for the river as what has to do with lateral migration. And at the bottom, we can see how the river moved along the years and how the lateral movement has been gradually decreasing. To understand this, we had the idea that geology impacted a lot. We had to study what was a historical dynamic of the river. We don't have satellite images, or we have very limited images. So we have made a study from paleo channels, that is the native channels. And one of the main objectives was to determine if there was a migration of the river laterally, or if it was being cut. And we determined that there is an area between Boca Colorado and Inambari that Leo showed us to. He showed results from that same area, and we can see
O sea, sí existe una gran presencia de scrollbacks, que eso quiere decir que el río se ha
that
estado moviendo.
there are many scrollbacks, and the river has been moving laterally and not through cuts. And there was a big dynamism in that area. Now, according to our study between 84 and 2019, when mining is developed, we can see that in older years we had some dynamism, but between 2012 to 2019, this has been quite reduced. This is why we could see a big drop as compared, in terms of displacement and meters. And in the last years, we had a cut. It was not a lateral displacement. We can see mining at the sites. Other parameters that we evaluated refer to average width. These directly evaluated parameters do not allow us to determine if there is a change in time, but we have, when we see the plant view, we can see minimum appreciations of how mining itself or this accumulation caused by extracting the bottom are acting as a riverine defense. For example, in the areas where there is a greater impact, we can see that we have a lesser width of the river and a big formation of islands, because they also exploit these deposition areas left by the river. There's a comparison between 1984 and 2019, and we had almost no mining at that time, but here we have active mining, and we can see how the mining extraction part surrounds the river and is in the islands as well, enlarging these islands and generating a larger number of subchannels in the river, which can show the influence of mining on the river width. This is our website, and it's called Dancing Rivers, and we have all these results. I'm going to change my screen now so you can take a look at our website. So this is the Dancing Rivers website, and we'll pass the link through the chat. We have rivers we have worked with, Guayá, Marañón, Ucayali, and also Madre de Dios. And when we select Madre de Dios, we can activate the morphometrics here. I'm showing the river width here and a time assessment so we can compare. If I choose 1984, we can see this. The river had this shape, and it was wider. And it was smoother. If I compare this with 2012 or 2019, we can see a larger number of channels, subchannels, that are not so smooth. And if I directly compare 2012 to 2019, we can see that we have more islands. You can take a look at this with lots of detail. We have the Madre de Dios River assessment from Boca Manu, which is at the higher part, and in Brazil already. And we determined these changes here. Another thing I'd like to highlight is that migration, for example, river migration, we have a lesser slope in this area, but this area does not have a big migration ratio. It's basically due to geological conditions. Here we can see that there's a limited amount of mining spots. Most of the extraction is at the Boca Colorado, Inambari, Huepetue, and La Pampa areas. Despite the fact that we don't have mining here, these changes have had a repercussion downstream. And also, depending on geological conditions, some areas, despite their low slope, do not have much river migration ratio. You can see this in a better detail in areas of more interest in the Dancing Rivers website. I go back to my presentation now.
Okay. Yeah. Ya, para pasar ya nuevamente a las conclusiones.
Now, to go to our conclusions, one of the main findings we've had is that we have realized that there's a decrease of parameters such as migration, and we have seen alterations in the erosion dynamic, particularly in the main river, Madre de Dios. The lateral migration of the river has considerably decreased as from 2012. However, this has been gradual since 2006, and this has been correlated with the increase of mining activity in the river banks. Width and sinuosity have been altered as a direct consequence of aggradation. This is a visible consequence of this kind of activity on the riverbanks. That would be all. Thank you very much.
Gracias, Yulisa, por tu presentación.
Thank you, Lisa, for your presentation. Now, we have the work group on hydraulic modeling. They will present their technical results. The presentation is by Carla Paiva. She has a BS in environmental engineering at UNI, and she is a master's degree candidate. She has experience in environmental monitoring and environmental emergencies in oil and gas industry. She manages databases and is part of her work at the National Water Authority. She is also a researcher in water technology in UTEC and is an advisor of the UTEC. In the river mining project, she is responsible for hydraulic and hydrologic modeling. Her research is focused on hydrologic behavior of the Madre de Dios River and sediment transportation in Madre de Dios and Colorado River. Thank you very much, Elisa. I'm going to share my presentation. Please let me know if you can see it.
Se puede ver.
Yes, we can see it. Very well. So I'm going to talk about the work we did on the modeling package of the river mining project and the study of a deforestation impact on the Madre de Dios river hydrology through hydrologic modeling with SWOT. I was advised by Dr. Pedro Rao for this work. The content of this presentation is to talk about the SWOT hydrologic model, how it works, how it functions. Well, this is the model, the study objective, methodology, results, summary, and conclusions. That's the content of our presentation. Now, the hydrologic model, or generally speaking, a hydrologic model seeks to represent different processes involved in river distribution and distribution of flows in a certain watershed. This is how it works, as you can see in the graph. It starts with rainfall, of course, and it includes different processes in the hydrological cycles, such as evaporation and evapotranspiration. At soil level, we have the plant roots, so there's infiltration, water absorption by plants, redistribution of humidity in the soil. We have surface or superficial runoff and also lateral flow. At aquifer level, we have the less deep aquifer. We have other processes such as return flow to the river and also recharge to the deeper aquifer. There are many processes involved in the hydrological cycle. This is why we need many variables, so we can represent the watershed we want to apply this to. This is why we say this is a physically based model, because it needs information on climate, topography, soil physics, and other practices that are applied in the model. So we applied this model to the Madre de Dios watershed, as Lea and Julissa explained. It's quite impacted by mining, and one of the consequences of mining is deforestation, which is what we evaluated in this work. The idea is to make the preliminary evaluation of the performance of this model in the Madre de Dios watershed, and then calibrate and validate this model. During this former stage, we applied 3 different plant cover scenarios that I'll explain later. The methodology the model uses, generally speaking, is introducing some entry data, some variables the model needs to know to apply the assessment of the hydrologic cycle. We can have an elevation digital model. We have a plant cover map, soil map. In our case, what we have used for them is 30-meter resolution dam. This is our study area. We have altitudes above 130 meters above sea level, and in the Andean part, 3,500 meters above sea level. The soil map and plant coverage map were taken from the global land cover characterization of USDS, and the climate data or hydrologic variables we use are daily rainfall and minimum and maximum daily temperature. We use the rainfall calculations of chirps with a resolution of 5 kilometers, and estimation of rainfall through a satellite that is available in a long time series. And this allows us to have rainfall distribution in all of our study area.
El mapa de cobertura vegetal que nosotros utilizamos y
the plant coverage map that we use, as I mentioned, evaluates 3 different scenarios in the Madre de Dios watershed. The first one
que sería el producto global
is the product of global land cover characterization with no changes. It's a product from 1993, and it doesn't consider much deforestation in the watershed. Scenario 2 is deforestation average, and third stage is a future scenario that is assumed with more deforestation. With all these entry data plus the coefficients used by SWOT, we can evaluate flows, sediment concentration, and surface runoff, and many more hydrologic variables, but these are the three main ones in the study. This is our study area. We go up to the Amaru-Mayu station, which has been managed by Tsunami since 2016. This is 55,411 square kilometers. It's quite extensive. The SWOT model divides this watershed in sub-watersheds and in hydrologic response units. And each sub-watershed belongs to a certain river area where we have the water balance and the exit variables.
According to the analysis and all of the data search that we've done in Madre de Dios, the measured real data, we've found the Marumayo station that's measuring the river at the outside of the basin with the Tambopata River. And we find a series since 2016 in September up to this point. In regards to the precipitation or raining or rainfalls, we see in different Puerto Maldonado areas where we also measure rainfall. Then we see an average, a monthly average of every year, where we can see that in the month that are the most humid one, which and then we see that the highest rainfall in December and the driest month are from June to September, with the least precipitation in August. So this precipitation here helped us to be able to assess how much this product is adjusted to what we measure here in Puerto Maldonado. And the best coefficient that we have is monthly, and that's why this model that I will introduce to you are simulations in a monthly time frame. And the temperature also. This is a daily average in 2016 to 2021, where we can see that the warmest months go from September to December, and the minimum is in July. So as I was mentioning, we had three simulations with the same data of rainfall and temperature, but changing only coverage or vegetal coverage maps to see how was it changing in this outbound variable. In scenario 1, we have a map with no modification of the product. Then in scenario 2, we've made a superposition of the first map with the deforested areas that have been calculated by Jorge Caballero and CINCIA in 2018. So we've done all this map, we got it together to represent deforested areas, especially in the basin of the river and Yuquín and Lambari. The third scenario is a scenario that we have planned out as an extreme, we can say, where we've deforested all the areas of Yuquín and Inambari rivers, given that we observed in 2021 a lot of deforestation alarms of the MINAM program in the area. These deforestation areas are not necessarily from mining, but also they could be from different causes such as timber and many other activities. So we developed this scenario to see what was the difference in the result of the model. The preliminary results are these sort of observed flows since 2016, as mentioned. So we can mention since that date with the simulated flows and with all of the conditions that I mentioned before. In scenario 4, or scenario 2, which is a process of that adjust to the most real scenario that we have right now in Madre de Dios. The model still has to go through a calibration and validation stage. We have a Nash coefficient of 0.5 that can be considered satisfactory, but it can be the closest to us. This coefficient measures how well are we adjusting what's simulated to what's observed. And we need to remind you that this was the only station that measures these river levels in all of this basin. Now, also, comparing the three scenarios and even understanding that this model has been calibrated, it can also help us to understand and to have an idea about the differences, the percentage differences that we have in different scenarios. Here we have some corrected maps of surface of water that's not filtered, but remains in the naked flow, we can say. And we can tell, we can see the graphs, especially in this area right here,
Subcuencas del río
of the Puquiri, Colorado, and Inambari basins, increases the corrected surfaces in area 1 and 2. So we can see that this generators can generate a higher erosion of the floor and condition the sediments that get to the rivers. And we can tell this in the same graph that it's a comparison between scenario 1 that we can remember it had no deforestation in scenario 3 that had an extreme type of feature, but we see clearly that the concentration of sediment could increase even quite a lot, and there's a lot of differences getting up to 85%, but in the outside of the basin. And this scenario of reforestation is in the higher side of the Kiri River in Inambari. And for the increase of concentration of sediment.
Bueno, eso ha sido
And
lo que
of course, that has been what we've developed with the SWAP model, which is simulating hydrology
que comprenden las
and
cuencas
that connect the basin with mining activity in the Boca Colorado, Puquiri, and Inambari rivers. And we can see
escenario 3
that in scenario number 3, we can increase even in 85% the concentration of suspended sediment. And we wanted to highlight the fact that in scenarios 1 and 2 that have minimum elements of deforestation, Puquiri and Colorado River are the ones that are shown special and sensitive to changes in the land coverage. That's why we need to put a lot of attention
Y por último,
to break this attention. And finally, the best development of the hydrological models and hydraulic also depend a lot on the amount of data that we have in the basin to validate results. So it is important that we need to highlight how important it is to have more stations that measure rainfall and the flow in the Madre de Dios region. That's all from me. Thank you very much.
Muchas gracias, Carla. A
Thank you
continuación,
very much, Carla.
Julio Araujo nos presentará los
Julio
resultados
Araujo will introduce the obtained results by the hydrobiology
Julio
team.
es doctor por la
Julio is a
Universidad
doctor by the PhD by the World University in Spain, biologist of aquatic environments in Neotropic with an experience of installation of
silvestre en lugares de
systems
interés
and wildlife in interest places for preservation. He worked in different projects of screening,
transformación del medio por la actividad minera en
transformations
actualmente trabaja como investigador
of environment due to mining activity, and right now he works as an associated researcher of the Wake Forest University and as a coordinator of the aquatic ecosystem program of the Innovation Center of CINCIA Amazonic Center in Puerto Maldonado, Peru, and he is the director of the scientific collection of the archaeology of Unamata. In the river mining project, he's responsible for the hydrobiology side of it and has directed a biological quake inventory in the mining basin. Please go ahead, Julio.
Buenas tardes, por favor, si me avisan
Good
si se
afternoon.
escucha.
Yeah, let me know if you can hear me fine or not.
Por la oportunidad que nos dan de compartir nuestro
Thank
trabajo.
you very much for letting us share my work.
Bueno, como hemos hablado anteriormente, nosotros trabajamos con CINCIA de
We usually work with CINCIA since 2016. And CINCIA is an initiative that with the American Corporation and Wake Forest University, we are going to make, I'm going to make a brief summary of our work that implicates or implies. Can you tell me if I have good audio? Yes, cool, you are good. Thank you.
Quería hacer una breve resumen de los
I wanted to make you a brief summary of the background. The backgrounds are studies developed in mining, where we correlate the environmental parameters, the deterioration of the basins, water, etc. We made a review, and we really think that we will have studies that do this type of work with this type of result in the Guianas area, and with all of the impact that it has, not just in the tropic, but also in climate certain hours where we don't have much background on it. But we do have work in Madre de Dios. And the work in Madre de Dios, I consider it's important because it's our experience. It won't always be
en la bibliografía, sin embargo,
or won't always be in the information of bibliography, but I do consider that it's a valid experience in many areas of the tropic and where we work artisanal mining, also in Africa. I'm going to make a brief summary that we've done. It's only an hydrological inventory that was done in November 2021. And with all of these limitants that it has, because
pues se pueden ver
in an
tendencias.
area such as this, we can see trends, but it's clear that we need to develop more. And but it's good for you to see the results that we are obtaining already, because I really consider that they are important and it will give us a lot more work to the results area, for example, in conclusions. All right. So the Madre de Dios Basin, you know, and you heard about it, you know it. I'll only talk about the mining corridor that's throughout the river, Madre de Dios, the highway axle in Ambari, and the one that highlights the most.
Un piedemonte que estamos
attention the most is a piedemonte, we have the slope and the flat area, and according to that ecosystem, we will have a different way of observing mining that will give us different environmental passes. I'm getting ahead of the methodology that I will introduce now, but I just wanted to let you know that this is the river part that was considered even before getting mining. We've had a series of points, and we've made them important and as the main channel of the river. As we've seen before, we have a different type of machinery that we work with that generating this type of landscape. So this is already being affected in transforming the landscape, and that's going to influence the water quality, sediments, and so on. That's the landscape that we see with this type of mining. And in the upper side, we are working with mining, but it's important to understand that from since the higher part, they already proposing to work. We have a front loader, and this is an activity that's not legal, but independently of this, in the since the 90s, we've been witness of this activity. Legal or not, it's important to understand how can we minimize the impact of this activity that so far we are not stopping the Madre de Dios river. Maybe it's something to avoid, so the sediment to come into the lower side of the stream. So we can understand that mining is not only causing harm with mercury, and our CINCIA colleagues are going to talk about mercury, but also the hydrocarbon principle. We have a lot of machinery in this part of the mountain, and we have a lot of waste. Maybe a month since we've gotten news about this wooden drag in place there. We know how small mining works on a small scale, but this will generate also an impact in the communities and in the type of environment that we find in rivers. Also, we have mining in rivers and mining in the mountain. This is in the lower side of the Amazon, that has a different way of working this type. And this is a mega in the Pampa area, and this is already affecting rivers. That's why it's important, and this will have a consequence, even though directly it's not in this type of mining that we're working with. This is a new method, and we are working in the forest. Downstream is what takes most of our time. We're not going to talk about that today, but this is a landscape that remains after mining. And we have a flat field. Some of the things that I've heard from our UTEC colleagues that mining could change river flow. And it's evident, for example, a case that we've seen in the control post of the Tambopata reservoir, where we built in the Tambopata or Malinowski River, and currently it's a temporary puddle because of the mining activity that we do. All of this will generate
cauces,
degradation of the flows, less depth for sediments,
claramente cuando vemos
the sediment, and when we see two rivers that get together, we'll understand that we might have a possibility. We detect the rivers that don't have a fish community. These Maya River that in 2009, 2006, with a impact study, it was considered, but then we see different species that we consider indicators to the studies that we've seen that have disappeared after the research due to problems with connectivity and the river that it comes from. And this cat, for example, this catfish is also affected. We see that this affects the livelihood of different types of life that used to be or exist in this area and not anymore. So what we have here is a proposal for research taking into account limitations, time constraints. Working with mining is really clear. To take forward and go upstream is not cheap. So what we did was to have a proposal where we have control points in the main canal and parts that have a free mining zone in Colorado and in Ambari, for example. And we have a theory or an action that means that since we are coming down from the head of the river through the course and through the river and the surroundings, we understand and we see vegetal matter coming into the river, but that starts gathering and gathering and gathering, and it makes the river to have a greater hydrological hierarchy, and that's going to cause an impact in our resources that in theory should remain or should keep a great amount of species. That's a premise that we are waiting for. This is not small, so we want to establish it. We have this phenomenon going on here, not validation of riches, and we have Madre de Dios River, we have 4 types of lines that are
Colorado
y Xirihue, and Los Amigos River, which is a pristine river with no mining impact. So with this premise, I will keep on going. What we've done is an analysis of the environmental parameters, landscape, low, etc., and aquatic communities. They will become human. So this will be a San Marcos Museum history type of work, and they do this type of study in Madre de Dios for all of it. So I'm not going to explain it all, but necessarily what we have considered to be important in function of the results and the way that we have a database that's left really big, hydrologically speaking. And to understand this, we need to go back to this, and what we found now is that the tip of the iceberg, or what we believe could be included due to the last sampling that we've had in the field.
O arrastre, pesca de arrastre, y después también con...
We put this here, we do this dragon type of scenario, we leave it at night, and by standardizing our efforts and the different sampling stations, we want to take samples of different microhabitats. We have beaches, we have we want to try to take the most amount of species or habitats that we want to get from that same location. And that's also going to be a sample for the Mercury program that we'll take later on. But then we have these meshes that go up, and what they do is standardize the surfaces, and we see how by scratching that surface, the current will introduce species inside of this, just like we have here. We did triple and we standardize it to compare stations among them.
Babilla verde,
Again, this green slippery thing that you can observe there in substrate being rocks. If they're not rocks, we can also take
es hacer
this type of rugged surface, and what we want to do is make an standardized surface for 5 or 6 centimeters, for example, to compare different characteristics. Once you have this surface, we scratch it, and that's going to be sent to specialists. Jorge Peralta, in our case, or Diana Babel,
nos va a dar este tipo de
is going
resultado,
to
¿no?
give us this type of results. We don't do it.
¿Qué tenemos acá?
What do we have here?
Pues acá tenemos algo que
Well, here we have something that we've seen, and it is that as we increase or we come into mining, we see that communities of preciso, meaning richness and abundance, will keep on increasing. We don't have a reason why this happened, or if it's water or experiment, but
está
the
sucediendo.
reality is that that's happening. We want to go back to understand why it is going on, but understanding and knowing what the channel is of rivers is the main one. This is what's happening. And we have species here that are plankton and indicators that have disappeared now.
Esta bonita foto nos ha hecho nuestro compañero, que lo dije antes.
Beautiful photo was made by Jorge Peralta of the Natural History Museum, and he is doing this type of research. We have something here that's different from what we were waiting for. In the higher part, we see a river of less hierarchy that has less resources to start with. Now we see less investment, but it has more richness downstream, and that's something that we are observing. We also see that we have species that are also disappearing from mining. We had them in the higher parts and we don't in the lower part, like Precopterus. This is a proposal of putting together a microvertebrate community, a definition of species, and what does it do? Each point is a species, and the number of individuals is represented when it's a maximum amount up and down, and the number of individuals for each species this side is only one. That's what we call singleton in our sampling, which is represented by one only individual. That singleton number is a maximum amount in the higher part where there's no an impact due to mining. However, we see that the microhabitat and this weird species or rare species decreases as we are coming into mining. And also, this could be also shown generating slope, what you can see here, and something that is a numbers is that we need to understand that this slope is really similar in mining areas. And when the environment is more preserved or pristine, the environment is smoother, and this is something to compare places among themselves, and this is something that macrovertebrates manage quite well, and we identified something we don't. Despite their existence,
Materia para el mercurio, como ustedes saben, hay muchas especies que son de consumo.
we have different types of fishing, and we have fishing activities that have to do with trade, with market, and food, for people themselves to have means of food. We have Sorobimlima, Serranos Combius. We need to understand what happens with this type of community fishes that are for consumption, and the same thing that we've seen before. We have species such as this, which are carnivore species that depend on the forest of facing the river, like for example, the Cambida. Graña. However, when we come into mining, communities change. What happens is that we have species that have a preference for mining, like this macala or this small fish. And this macana is one of the few references that I have where mining has been detected. It looks like this species is an indicator in its abundance, or could be related to deterioration of the minor. And what we've seen before, it's similar to what happens in microvertical in the higher parts.
Hay más especies
Without
que
the use of mining, we have more species than in the lower areas. Why? Because we have less offers of ecosystem or resources or whatnot. And we have an incident that doesn't come out as good because this was the only expedition. You need to repeat it. If I get a life cycle of a fish, I can understand maybe what happened. But it's only a small amount, and I was represented 80% of individuals. These are things that happen, but
la minería
at the
disminuye
beginning,
la
the trend
riqueza.
is same mining to enrich mining, and then we have this type of problem going on. So, what is it that we have? What we have is that it's evident that there's harm in ecosystems and the chemical consistency of the water due to mining, and then we've described how communities change, but also we've specified
La presencia nos puede
which study or presence can help us understand with different type of parameters that probably they are, or the conditions are getting worse and harming species. And the last thing that I would love to do is to go back to those places and do those studies and to confirm what I've had up to now. Or is it the fact that we might have inconsistency? So it's good that we've created the attention to go back to those studies of area. Thank you very much. And if you have any question, I can answer them further on. Thank you very much, Julio. Up next, Claudia Vega will show us the results of the pollution group by mercury. She's the coordinator of the mercury program in the scientific innovation center from Wake Forest. She's the co-director of the first lab of mercury and environmental chemistry in the Madre de Dios region. She studied veterinary medicine and then she obtained her master's in public health and environment in the National School of Public Public Health of Brazil, where she contaminated study research about heavy metals in birds and Janeiro, where she studied the interaction of selenium and mercury in river-like communities in the Madeira River of Rondônia. Afterwards, she developed her PhD in the National School of Public Health of Brazil, where she studied pollution of mercury in indigenous communities in Anomamis. So far, she had around 10 years of experience studying the exposure to mercury. She has published some scientific articles in international magazines about this issue. In the river mining program, she leads the contamination by mercury program. Thank you very much, Claudia. Thank you very much for the presentation. As we said before, and before starting my presentation, I would like to say I want to thank you first and the UTEC team because it has been a really enriching opportunity to work together. And I also want to say that I'm also introducing the work package of Mercury, but there's a whole team behind this work package. I had the opportunity of working with Veronica Moreno, working a lot with Fernandez, our director, who is also an expert in Mercury, and with the support of assistants of Maria Paz, Carla Cisniegas, Julie Estrada. Thanks to them, this presentation's here. And I'll show you what I've done, and I'll show you what we've done with the other work packages, as Julia mentioned, as a part of a show that we analyze, and we could give you a bit more about hydrodynamics, so that because it helps us understand what's happening with mercury in the Madre de Dios basin. And as I mentioned before, the work package measures this impact. And before speaking of it, I only wanted to make a brief introduction to this topic. Sorry.
Bueno, primero presentar a
First, I
Mercurio.
would like to introduce you to Mercury, the star of this presentation. And only to make a brief introduction, and you know that I think you all know that Mercury is a special metal. It's the only liquid metal, and this liquid metal has special properties that make it more interesting to study this element because it moves around easily in room temperature.
Tiene transporte
It
atmosférico.
has atmospheric transportation and also accumulates in a traffic chain, and it has a biomagnification property. And we shouldn't forget it's a toxic element. That's why it's so important. And that's why we have a huge concern worldwide about this metal, categorized by the World Health Organization as one of the 10 most concerning substances for public health. And despite that, we need to remind and to remember that man has not created Mercury. Mercury is a natural element, and that's why it has natural emissions in the world. And that's more or less those emissions represent 10% of global emissions. And then we have anthropogenic emissions, and that's due to the man's activity. That might be artisanal mining, can be carbon burning and industrial mining. Now, I didn't mention that before, but we have also botanical emissions, thermal, and deposits of natural mercury. So those are two sources, and together represent 40% of the global emissions. But we have a third source, which is the emission that represents 60%. What does it mean then? The mercury can move from one compartment to the other, and if you can see that mercury there is in the floor, and it goes through erosion to aquatic systems. When we also burn vegetation, mercury at present is in the ground and can be issued to the sent to the atmosphere. So we want to be reminded about this detail because it will help us to understand the results that I will show you. If you see this graphic here, this yellow circle, which is from the last report of the United Nations of mercury, you can see the yellow part there, and you see the biggest part. You can see that small scale gold mine, and that represents mercury emissions. Over 40% of the sources that come from human source are represented by human mining. Artisanal mining is the main source of anthropogenic mercury globally. So what happens? The anthropogenic emissions of mercury have increased in the last 5 years with over 20%.
No sé si lo sabían, pero
I don't know if
Sudamérica,
you know, but South America, in the emissions of artisanal mining is like about 50% of mercury that comes from this place. Then it's Asia, and then Africa.
o sea, nuestra región es una de las principales
So our
emitoras.
region is one, the main producers of mercury, or this emissions of mercury. That's why we need to try and understand what's going on with this mercury in the environment. As we know, this is a study placed in a research center, and since the last part, we estimated that around 181 tons were issued by this activity, and this was one of the last reports. And before that one, we had a different one with different estimates that were lower, but as of 2018, and right now we don't have any other updated of 181 tons of mercury. So we know that this activity or artisanal mining is the one that's the main one in Madre de Dios, and that will allow us to have a greater amount of mercury in the environment.
And to think about mercury, I always say that we're going to talk about something we don't see. We can see sediments, fish, the river basins, etc. We can't see mercury, but it's all over. Imagine what you are seeing here. This is mercury all over, air, water, soil, everywhere, even our food. If you see at the bottom, you can see that in water body, we have inorganic mercury that is not absorbed biologically, but when it goes to the water, it becomes to MEHG, and it's important to consider this because it's a mercury transformation that occurs in water bodies because of microorganisms, and this metal mercury can be absorbed and is one of the most toxic mercury forms. It is transformed in water bodies, concentrated there, and reach to top predators with greatest concentration, including people, right? So this is mercury layer lower that can move from one place to the other. And let's remember what I said about anthropogenic activity like water felling or burning vegetation can make mercury that is in the soil and vegetation be emitted to the atmosphere or reach the water bodies and suffer a number of transformations. So with human activity, it can move and reach the water bodies and also be emitted to the atmosphere. And this mercury that is re-emitted accelerates its movement. And with mining activity, we know that miners use mercury to extract gold because it forms doré, and then we have gold. So it's directly poured into the environment too, through the mining activity, and that's not a natural mercury. So our research question: how gold mining affects mercury levels in the Madre de Dios River watershed. The main objective of our research was to characterize the levels of MAPE in the Madre de Dios watershed. What do we need? We need to have indicators like sediment and fishes, suspended and bottom sediment and fish that is collected in the study. When we study mercury, we study concentration in different matrices, but now at UTEC, we had the opportunity of doing hydrodynamic parameter measurements to better understand this dynamic of mercury in sediment. These parameters were collected together with the mercury samples. Then we determined mercury in environmental samples. Then we related that to variables and how they interacted. And also one of the last objectives in the study was to determine mercury isotopes in sediments. As you can see, mercury can be natural or anthropogenic source. So this is the tool that helps us to see if mercury is anthropogenic or natural source. And that methodology is also contemplated in this project. To begin with, I think you have seen this map a lot. As you can see here, we have all these sampling spots for mercury. In the Madre de Dios River, it was collected in sediment, suspended sediment, and bottom sediment. And all this area of the Madre de Dios River that is mainly impacted by suction pump mining. In Colorado and in Ambari, we also collected just suspended sediment, and you use a different methodology. We don't have the hydrodynamic parameters here, because we weren't able to take the equipment to measure there. But we were able to collect suspended mercury to understand what happened. Suspended sediment, sorry. So we have 10 spots for collection in Madre de Dios, and in Ambari, Colorado, 8 collection points. The orange and green areas are the mining activity areas. If you see MDP 08, this is our control area, what we chose as control area. It's upstream of mining activity, and we see more of a natural mercury behavior there. So we have a control site and the effective site. Sampling of suspended sediment was done in the field. We collected water at 1 meter deep. We filtered in the field, and what we couldn't filter in the field, we filtered in the lab. And why? Because this is reported as a mercury vector. Mercury is joined to these small sediment particles that are in suspension. And as I said, in the Madre de Dios River, we also collected bottom sediment. All the samples were taken to the Mercury and Environment Chemistry Lab in Madre de Dios. It's the first lab of the Peruvian Amazon that is devoted to the study of mercury in the environment. It's a collaboration between Wake Forest, USAID, and the Center for Amazon Scientific Innovation and IAP. What did we observe? In this first map, we can see what we got. The red and blue figures are mercury in suspended and in mercury in suspended sediments, and blue in bottom. If you compare red and blue, most of the mercury is in the suspended sediments. So mercury travels in those small particles. When we study mercury, we have to study it in suspended sediment. In all the bars, you can see that bottom shows bottom sediment shows very small concentration. That's not a good indicator of mercury in the river. In the control area, take a look at the colors of the bars. In control area, there was less mercury in suspended sediment. When we reached Colorado, it increased. You can see the circle increases in color too, and there is an increase in the mercury concentration in the river. In the Madre de Dios, until before the Inambari section, it's smaller, but when we start there, it's higher. We know that in Ambari, we have La Pampa drainage. That's why we have this contribution to mercury to the suspended sediment in this river. And as from Inambari, we see an increase. In this last point, the mercury concentration in suspended sediment is quite high. Here, you can see that the last point has gone through the maze area that we know has a lot of mining in that area. So water is collecting mercury that is used in that activity. The size of these circles is the water flow in the river. It increases in the lower areas, of course, and you can observe that sediment concentrations increase too. At the last point, we have quite high mercury concentration and also suspended sediment that transports mercury. So if we have these parameters, this is what we could observe. This map shows the mercury concentration and the load of mercury in tons per year. You can see the wheel size, which shows the load of mercury in tons per year. Before reaching Inambari, that mercury load or transportation is less than 1 ton. Now, when we reach Inambari, it goes to a concentration that exceeds 1 ton per mercury per year. And when we reach the last point, that mercury load reaches 12 tons per year. So what we can see is that the mining activity is impacting the mercury load transported in the sediment, and that suspended mercury load in water and mercury concentration in that sediment. What we can see in these other points in Colorado and Inambari is that we don't have a large sediment circle here because we didn't study the hydrodynamic parameters, but we can see that there is a very high concentration of mercury in suspended sediment at the Inambari. So the Inambari has a great contribution to the Madre de Dios water basin in terms of mercury load in this watershed. And this leads us to our final conclusions. There is an impact of mining activities on the mercury load. That's in the sediment matrix. But as I said at the beginning, when we apply it to the cycle, mercury is transformed in water bodies in methyl mercury, and it's one of the most toxic forms of mercury, and fish consumption is the main exposure to mercury for human beings. We also collected fish for sampling of mercury, and these are all the collection points. Here in this Ishiriwe area, we have the control area in Boca Colorado, MD2 in Ambaria, and MDD1 were sampling in impacted areas. First of all, we observed a bioaccumulation phenomenon. The larger the fish, the bigger the amount of mercury. In carnivores, it's even greater. We know that adult fish concentrate more mercury than young fish. Well, we wanted to see a trend of mercury concentration per studied site, and we didn't see a clear trend in all studied sites. But it's because impacted areas had a lower collection of individuals because it was not easy to fish there. So that the N in these impacted areas was lower. And this is why we couldn't see a clear trend. In some areas like Madre de Dios 3, there's a clear trend. But it's not clear in all points because we couldn't collect herbivores or omnivores in some sites. So we could not see it as we saw it in the control area. However, to know if the presence of mining activity impacted mercury levels, what we did was to compare collected fish in control areas with collected fish in areas affected by mining. In all trophic levels, the difference is significant, particularly in areas affected by mining. Here we see the biomagnification phenomenon, that is that mercury is more concentrated in top predators as compared to those in the first levels of the chain, like herbivores or omnivores. What does this mean? That there's a greater risk of exposure of mercury for carnivores. We always say that fish consumption is the main source of exposure of mercury for humans. Now, what happens to the fish? As we said at the beginning, mercury is a toxic element. In studies, in a revision of studies, we could see that there was a concentration of 0.02 ppm in fish, which represents a concentration beyond which we can see toxic effects in fish. And that also affects population and reproduction, as well as an impact on the ecosystem and on fishing. When we talk about human consumption, WHO has established 0.5 ppm of mercury in the fish muscle as the limit level. And we see that they are greater in places affected by mining. As I said before, fish is the main source of exposure of mercury for humans. But it's not only humans, Madre de Dios, it's a hotspot of biodiversity. There are a number of species that depend on water organisms and fish. And this is a river otter that eats fish, and we don't know what impacts these areas there can be in these areas affected by mining. So our conclusions: the mercury load is increased downstream of mining activity in the Madre de Dios river basin. The Inambari River presents the highest concentrations in suspended sediment, and one of the biggest contributions of mercury to the Madre de Dios River. We also have mercury concentrations in fishes of affected area, and they are greater as compared to control areas, which represents an ecologic risk. What we showed is that there are higher levels in impacted areas, and this can represent a greater ecologic risk. We don't have the results of isotopes yet. We do know there are more concentrations of mercury in impacted areas, but we don't know if it's natural mercury that was in the soil and that because of deforestation got into water bodies, or if it is the mercury used for gold extraction. We'll have the results of isotopes at the end of this month in a study that we will publish at the end of this project. That's the message I wanted to leave with you. Thank you very much. If you have any doubts, I'm here for you. Thank you very much, Claudia, and all the lecturers for their presentations. Now we will have some minutes to answer to questions. And some have already been answered in the Q&A box. We have a first question for Leo Guerrero. It says, is it common to find, well, it's common to find illegal mining close to rivers, and if that is so, why is that?
Sí, evidentemente.
Yes, evidently, we have to take into account that the sediment is the one that has the gold, and that's why most of the mining is done in areas where the river has been present, in the river valley, in the river basin.
Algunos pues van viendo si es que hay buena calidad de oro.
Then they start checking the amount of gold they get and if it's good quality. But it's because the sediment is the one that brings the mineral. Thank you, Leo. We also have a question for Carla Paiva. In sediment concentration simulations, it was interesting to see that in scenario 1, there were 2 peaks. But in scenario 3, there weren't 2 peaks, but just 1 and a bit rounded. Besides an increase in sediments, why does this happen? And what are the effects these differences can have in the river? It's a good
causas de que ese pico se llega a estabilizar.
observation. Actually, it's difficult to
Llega a un punto de saturación de repente el agua. Pero en todo caso el aumento.
Perhaps it's because there's a level of saturation in water, but it can have lots of consequences. As has been commented, accumulation of sediments can change the river morphology, as Yulisa mentioned at the beginning. And also it has to do with the fact that the hydrobiological species environment changes and they can be polluted with mercury, as we saw in the last presentation. Those are the possible effects. Thank you, Carla. We also have a question for Yulisa Estrada. For information on the average width, how do you take into account climate variability with rainfall, with not so much rainfall, wider, narrower? Yes, of course. Climate variability and seasonality are taken into account because there is a dry season and a wet season. To standardize that, we have used a period that is comprised between March and October, which is the transition from lots of rainfall to dry season. This was to have some standardization and also because of satellite image availability. During high rainfall, we also have lots of clouds, so it's difficult to get images. That would be all.